So a while ago, VDIAGTOOL sent me the V200 to evaluate and show you guys a video. And so since then, they have came out with the V200 Pro, and essentially it's the same except for it now has a circuit breaker finder as part of this kit. So let me go ahead and open this up. And while I'm opening, I'll pop up a little graphic to show you the video. So again, please go check that video out. And definitely that video was quite informative. And this video right here is going to be even more informative than the last one, as you will come to see. All right, put this box over here. I just want to just show you what you get in the box here. Go ahead and open it up here. V200 Pro. You get very long extension cord. First of all, you may not ever even need this, but again, if you do, you have it at your disposal. This unit comes with a very long, let's take this off here. This is the actual V power probe itself. But the difference with this one versus the other one is that this one now has a red cable on it that this is going to be used in conjunction with the actual circuit finder. You also have a 12-volt adapter if you need that. Here's your for connectors, alligators, clips for batteries. Here's your tip. You also get a nice owner's manual as well. And this here is the circuit breaker finder itself. So with that said, just put everything out here on display for you so you can see this, so you can see exactly what comes in the kit. And from here, I've had some good demonstrations already set up, and we'll go from there. And again, this video will be much more informative than the video with the V200, so let's get into that. All right, so first things first. So what I want to show you first is that if anybody's watching who's not familiar with the circuit probe, exactly what's going on here, and then we'll proceed to giving you some examples of how to use this and show you the features and functionalities of this unit. So first of all, you have the probe here with this tip connected, and it's ran, if you look through this wire, and it's going all the way to the battery. As you can see, I already got the positive side connected, and here is the ground side I'm about to connect. But let me bring this over here a little closer. So when you connect this is what cuts the, let me see if I can get this straightened out here. There we go. When you connect the ground, the unit turns on, as you'll see here. So there you have it. The unit is now cutting on. And so the first things that you would notice is that it says 0 volts. Okay, let me switch hands here. All right, so go back here. All right, so back to the normal voltage. So if you push up, what this is saying is that, you see that says 12 volts. This is saying that when you touch this tip to something, you will apply 12 volts to it. All right, so if you push down on this arrow, I hit that button again, sorry about that. If you push down on this arrow, you see that it says 0 volts. So if you touch this tip to a component or wire, you will be applying a ground to it. And this is very useful for testing circuits, as you'll see here in a minute. Now, you also, because this is connected to the positive and the negative at the same time, you can just touch things and see what type of polarity it has. Like, for example, if we take this tip here, right here, and touch the negative terminal here, you see that that turns green. That's saying that that's negative. And likewise, we go over here. I'm trying to make it so you can see it. Sorry, it's a little to the side. When we touch the positive over here, right here, the screen turns red and it shows 12.7 volts. And again, I am not pushing either one of these arrows here. And you don't want to push these arrows unless you are for sure that whatever you're applying voltage or ground to, 12 volts or ground, that it is complementary to whatever you're setting it to. Because, so for example, if you had a hot wire and applied power to it, you just might like pop a fuse or, actually burn a component, for example. Or if it's a 5-volt component, you want to be careful with that as well. All right, so what can we use this thing for? Okay, let me turn around. My first example here is sitting right here. Let me turn the camera down so we can see. All right, if you see this light here, so just imagine I'm going to connect this right here, this green right here to battery negative for this example here. Connect that right there to the battery negative. All right. So just imagine if this is a tail light to your car and for some reason it's not coming on. So the first thing you obviously want to do is check power and ground. And yes, you could do this with a typical test light, but this thing gives you much more control here. Like for example, if you see this thing here, if I touch the wire here, it shows that, okay, we got a ground here, for example. All right, it also shows that now if I touch this wire and this is not connected to power, let's just make us and for the example that this wire is disconnected somewhere in the circuit. If we touch this wire here, it also shows a ground, right? But now watch this. Now if I push this down, now that's applying 12.6 volts. If I touch this tip to the wire, take a look at that bulb, it just cut right on. All right, you might say, well, okay, you also can test at the component as well. And this could be anything that would take 12 volts in this case. So this light bulb take 12 volts. So let's just say, all right, we want to test the component. So you could, again, press the up arrow, apply 12 volts, and then insert your tip into the back probe here. And there you have it. The light cuts on just like that. So basically, you can take this thing and test at the component level, and you also can test like back probe in the circuit in different places to see if the circuit is broken, okay, with this here alone. But don't forget, we'll get to the circuit breaker in a little while. All right, so for the next example, I'm gonna reset the camera up over here. We're gonna go over to the relay box. Some very important things I want to show you with the relay, and we'll jump into that one next. Before we jump forward to the relay testing with this unit, I just want to show you some of the features here this thing has. Like for example, you can do AC voltage here, as you can see. If you click this red button, it goes over to frequency and AC voltage. Now this would be good for testing alternators. I'm not going to test the alternator here in this case here. I might do that just as a YouTube short just to show how that works. But what I really want to show you, if you go here, hit the red button again, it goes over to resistance, and that shows an open loop. But check this out. I'm going to show you the limit. This here is a 100K resistor. So you would just put it in this plug here. And then when you touch this, let me make sure get it in the screen here's good. So if you touch this here, you can see that it will accurately measure up to 100,000. And this one here, I'm gonna show you another resistor here. This is right here is 1 million ohms. So the limit, I believe, might be 100,000 maybe. Not entirely for sure, but if you test 1 million, it still just says, hold on, let me get that in there good for you. For some reason that one won't stick in there. Okay, there we go. So if you test this one here, and touch it, it just still says open loop. So that is the limit of this thing. It seems to be 100,000. Now, moving on to the little diode testing section. Again, you hit the red button and you'll see this thing move to the diode testing section. It just shows, just the graphic for that. So now watch this. If we put the diode in the correct direction, now the diode is basically just like if you don't know what it is, it's basically like a electrical check valve. Electricity can only, I believe, only flow in one direction, but not in the other. I guess it's used to protect circuits, I guess, or one way, like a redundancy. So in this diode testing mode, as you see here, if we go ahead, let me see if I can get this into focus here, and as we touch this, it shows a forward bias, no problem, right? Now, if we turn the diode around, and don't forget this is directional, and if we touch it, what happens? Nothing happens because it only flows in one direction. So anyway, you can do some other, this right here is sort of a, has multimeter features here that actually come in handy. I don't know how good it is, but it seems to be functional and good enough, say like if you're just under the hood and just need some really quick answers to help you with your electrical diagnosis. So now let's go jump under the hood, back under the hood to the relay testing. All right, here, so we're now at the relay panel here, and I'm gonna show you, this here is a typical, if I can get this under some light here, this is a typical 5-pin GM setup here. And well, you know, pin 85 and 86 are what's gonna be the control side, and I'll throw a schematic up here. And once you energize pin 85 and 86, the normally closed side will close to the normally open side and complete that circuit. So in order to test this, basically what I'm saying is that you would apply negative voltage to the 85 pin and positive voltage to the 86 pin. So we're gonna go ahead and test that out right now so you can see exactly how this works. So I'm gonna step back over here to the bench here. Let me grab a little light. And so if we take this, hold on, forgive me 1 second here. I gotta straighten something out here so I can see here. If we take this pin here, you can turn this down, turn my camera down so we can see what I'm doing here. Yeah, let's see if you can see in there. You can see, should see the numbers in here. This right here is pin 85 here. This is pin 86. So basically you would take your negative, put it on pin 85, and then you would take your positive and go to pin 86. Let me see what's the best way I can do this so I can show you. Okay, here we go. And we go to pin 86. So don't forget, let's go back to the voltage. Push this forward first. Then we touch 86. Let's see if you can hear that. You hear that? See how that's checking that relay. So let me show you. Get it close to the mic here. I'm sure you can hear that. And I'm sure you can hear it all the way out here as well. So I'm gonna just demonstrate that one more time. But suppose you say, okay, my relay is working, what next? This relay right here came from my wiper, by the way. So what about if the relay doesn't work? See, that's where you make a decision on what to do next. Let's just say the relay was not working, or was working, and you wanted to say, hey, because this right here works. If you look, let's see here, let me get this situated here so you can see. Now, if you see my wiper arms back here in the back here, right here. So basically that's what I want to test. So I've already got my back probe right here set up. So this right here would be what pin 30 is at on the relay, okay? And don't forget, this is 12 volts. So make sure if you're applying 12 volts to something, it actually takes 12 volts. So you can back probe, back probe pins. So let me show you how that works here. First of all, if we just go down, okay, first of all, I'm gonna try to, this is gonna be a little awkward here for me, but you see this little, I'm gonna hold this down. Oh, maybe, yeah, let me hold it like this. Here we go. Give me 1 second here. A little fumbling with my camera here, hold up. All right, so if I hold this down, apply the 12 volts, and stick it into this back probe here. Look at my wiper arms are moving. So that means that from here, from this point forward to the wiper motor, everything is working. So if I had a problem, I would need to go not to go towards the wipers, I would need to go back towards the power source. So that's one way you can use this. Another way you can use this tool is that you can check relays with it, and you also can check electrical motors by applying, for example, electrical motors or components by applying power source to that. So, all right, so let's jump over to some bench testing, and then I'm going to wrap this up with demonstrating the circuit breaker finder. All right, so now we're at the bench. Just imagine we wanted the bench top test the starter right here. As you can see, I already have these two right here jumped like you should have normally on when you're testing starters. I have my ground planted here, and then you can just take a power, go ahead and apply your power, and then just touch this, and as you see, you can just bench top test your starter just like that. So now, turn back around to the car. I'm gonna do a setup with the circuit breaker finder, and that'll just go ahead and wrap this video up. All right, before we set up the demonstration here, I want to show you what's happening with this signal trace and how it actually works. Now you see on this little switch here, it's in position 1. But if you switch it to the middle, that turns the unit off. But now nothing happens because, for example, if you take this probe, press the button, all you hear is just radio sounds inside of it because there's nothing happening. But now, when you turn it to position 2, what's happening is that it's sending a little signal through this wire. And let me show you, as you get, now when I hold the button down, you hear that as you get closer to the wire, it gets louder and louder. So let me back up here so you can see what I'm saying. So for example, if I'm over here and I get closer to the unit, you can see that. So basically, as long as it can detect this signal, the circuit is not broken. Okay, so that's a big deal. And also, you can turn the volume up and down on this so it won't be obnoxious if you're working around other people in the shop. It also has an option under here to put a pair of headphones in it as well. So I just wanted to show you the general overview of how this right here, the actual circuit breaker finder, interacts with this signal output here. So now we're going to turn around to the car, set up an example, and show you how that works. All right, so now we're out here under the hood. Now we're going to do the little circuit breaker finder demonstration. Let's go ahead and cut this on. As we can see, a signal is still coming through this wire here. But if we take this alligator clip and connect it to this open loop on this bulb here, we hit this. As you'll see, that's connected. So now when you hit this, you don't have any signal. Okay, but let's go over here to this mass airflow sensor here. We're going to go ahead and connect this up here, back probe this wire here, put that there. Let me get the signal finder. So now when we hit the signal finder, look at that. Perfect. Signal is going, and you can trace it through wiring harnesses anywhere you want. And basically, you can ultimately go and see where it's kind of, you know, that it can go all the way over to the ECU. So, for example, we know that this wire is somewhere in this pack of wires right here on the bottom, as you can see right here. Let's see if I can get that into focus here. Because, for example, you go up here, it's not really making any noise, but you put it near this one. So you know that, hold on, let's see if I can get that focus here. You know that this wiring harness right here, this is the circuit has been completed at least to here. And that can help you with your diagnosis. So anyway, I hope that you like this demonstration of the V200, this V200 Pro automotive circuit breaker finder. I hope this video has helped you out. Again, I can highly recommend it. I'm pleasantly pleased of how easy it works, and really the price as well, and the customer service from these people. So if you're in the market for a circuit tester and a circuit breaker finder, this would be one to take a look at.